In this video, we're going to take a look at the law of sines. And we're actually going to derive the law of sines in this video, and then in the next video, we'll look at some examples of how to use the law of sines. So an oblique triangle is one that does not contain a right angle. So in other words, either an acute triangle where all the angles are less than 90, or an obtuse triangle where you have one angle that's bigger than 90. So to solve oblique triangles as well as right triangles as well, we can use these techniques as well for right triangles. You can use either the law of sines or the law of cosines. Now, when we say to solve a triangle, what we mean is find all missing angle measurements and side lengths. So in order to do that, we're going to use the law of sines or the law of cosines, and we'll also know when to use each one. So the good news is there is a sort of a preventative measurement in place to make sure you don't end up using the wrong one and get something wrong. So the law of sines, we're going to show in this video where it comes from. So we're going to derive it. And then again, as mentioned earlier in the next video, we'll look at some examples. So we have a triangle here, triangle ABC. Remember that the angles use the capital letters, the sides opposite those angles use the lowercase letter. So side A opposite angle A, side B opposite angle B, etc. So when we talked about sines in the past, we used them in terms of right triangles. So we don't have a right triangle here, but what we can do is we can pick one of these three vertices, either A, B, or C, and draw an altitude. So I'm going to draw an altitude from angle C to side C. So remember, altitude is the height of the triangle, and it's perpendicular to the side that it intersects. In other words, we have two right triangles here, one on the left and one on the right. So if we break them apart, almost like breaking up a Dorito, we get two separate right triangles. So we'll call this intersection point here, we'll call that point D. So we have, first off, we have this triangle, this right triangle on the left, right triangle ADC, and then on the right we have right triangle BDC. And notice again that the values here are the same height for each triangle, so we didn't really change anything. As far as what we took with them, the triangle here on the left has side B as the hypotenuse. The triangle here on the right has side A as the hypotenuse. So using these two triangles here, for our first one, we have the sine of angle A is the opposite y over the hypotenuse B. And if we multiply both sides by the denominator, we'll clear out our fraction. We get the height of this triangle is the length of side B times the sine of angle A. So this represents the height of this triangle. Likewise, over here, we have the sine of angle B equals opposite y over hypotenuse A. And if we want to clear out this fraction, we can multiply both sides by A, and we get A times the sine of B equals y. So this height is the length of side A times the sine of angle B, which is the same height as we have over here. So because these two expressions, B times the sine of angle A and A times the sine of angle B, because they both refer to the same height of the triangle, they have to be equal to each other. That's your transitive property. Two things equal to the same thing must be equal to each other. And then if we from there divide both sides by A times B, which because they're lengths of a triangle, they're not going to be zero. If we divide both sides by the product of A times B, we'll get these b's to cancel out, and we'll have the sine of angle A over the length of side A, and these a's will cancel out, and we'll get on the right-hand side the sine of angle B over the length of side B. And this is the law of sines for angle A and angle B in that triangle. And it turns out we can extend this. If we wouldn't have picked A and B, let's say we would have picked B and C, we would have gotten the sine of angle B over B equals the sine of angle C over C. So if we would have drawn our altitude from A instead of C, we would have gotten sine of C over C, which our law of sines is nothing more than an extended proportion. So it's the sine of angle A divided by the length of side A is going to equal the sine of angle B divided by the length of side B is going to equal the sine of angle C divided by the length of side C. So it's not a very difficult law or formula to even have to remember, because your side length is directly below your angle. Now you could take the reciprocals of all these and have A over sine A equals B over sine B equals C over sine C, but we'll just stick with this one because it's easier. So, all right, so in the next video, we're going to look at some examples of solving triangles using the law of sines. So I'll see you then.